Let's do some examples of composition of transformations. The first one here asks me to find the coordinates of point A, which is originally at -2,5 after the described glide reflection, and it tells me the translation and the reflection that are supposed to be occurring. The next one has a picture and asks me to use that to figure out what composition has occurred. Make sure you pay attention to what's the prime, what's double prime, and what's just the original points. Go ahead, if you think you might be able to try these, go ahead and do so. Hit pause, try them, and then I will talk through them with you. Okay, so here I have written down what I'm being asked to do on the first one. I'm being asked to take the pre-image, which is point A, and I went ahead and wrote it as 2 steps because that's really what we're doing. We're doing step 1 and then step 2. After we do the first one, that'll be our A prime. So let's see what we get after we do this translation. This translation tells me I'm going to subtract 3 from my x value, which is the same as saying left 3. Then it tells me, so let's go ahead and do that. A prime, 3 subtracted from this gives me -5. And then it tells me I'm going to subtract 3 from my y value, which is the same as saying I'm going to go down 3. If I'm starting at 5, 5 minus 3 is 2. So here's the point where I am after step 1. But since this is a composition, I'm going to keep going and do something else to that same point. Sorry for the bells. So next thing is telling me to reflect across the x-axis. Well, that's something I have a rule for. The rule for reflecting across the x-axis is that the sign of the y will change. And that's the only thing that will change. So first I went from here to here. Now I'm going to go ahead and do that, and I get a double prime, which is going to be my final image. And the only thing that changes is the sign of y. So here is my answer. And that's example 1. For example 2, I've just drawn a little sketch. And what I want you to notice is I only did the first step. Sorry, this should have a prime. Because really you have to look at these step by step to be able to figure out what happened. You don't need to look at it all at once. So the very first thing I'm looking at is how to get from here to here. And the fact that my orientation has changed, meaning it used to be up and down and now it's side to side, means that it's definitely have to be either a reflection or rotation, because remember translations don't change orientation. And what happened here is a rotation. It has rotated 90 degrees clockwise about the origin. And what I mean by the origin is right here. And we can check that by using coordinates if we want to. My original coordinates here were -1, 1, and that became 1, 1. And I don't know what these were because I'm not looking at the same picture, but you can check the coordinates for Q as well and make sure that it fits the rules that you know for a 90 degrees clockwise rotation, which remember is the same as a 270 counterclockwise. Now the next step is it looks like the whole thing moves down 3 units. Okay, so P double prime is here, Q double prime is here. The whole thing has moved down 3 units. So down 3 means the y values are subtracting 3 or going down by 3. So this is at 1, -2. And I had to come back here and look, and since the Q was originally at 5, 1, it's going to be at 5, -2. So that fits, but we have to think about what this is. If you're just sliding it down and it's not turning or flipping over anything, remember that's a translation. So this is a translation. And the rule for this translation tells me the x values are staying the same. The 1 and the 5 stay the same, but the y is decreasing by 3. That's the same thing as saying it's been moved down 3. So my whole answer would be a 90 degrees clockwise rotation followed by a translation down 3. Or if it asked me as for a rule, then I have to put it in this way. But if it just asked me to describe it, I could just say down 3. Okay, so this next thing it is asking me to do, it says, show that each of the following pairs of figures is congruent by describing a mapping of the original onto the image. In other words, they're asking me, remember a map tells you how to get from one place to another. So they're saying describe how to get from the original onto the image. Describe the composition of transformations shown below. All right, now the interesting thing here is this is the first time we've been asked to show congruence by mapping. So what we have to remember is that reflections preserve the size of the figure. Rotations preserve the size of the figure. And translations preserve the size. Preserving the size is the same thing as saying it keeps the size at the same. And we know that when things have the same size, that means they're congruent. Whoa, congruent. So anytime I'm doing a reflection or a rotation or a translation, I'm keeping things the same size, and so my image and my pre-image will always be congruent. So we can think of that. That's why these are called isometries or rigid transformations. All three of these is because they do this. So let's go ahead and say, I'm going to give it a different color. These are isometries. I didn't give it a different color. I will in a second. Or rigid transformations, because they do exactly that. They preserve the size, which means that my original and my image are going to be congruent. So this can be used as a way of showing that things are congruent by showing that if I need to, I could move from one to the other by a reflection or a rotation or a translation, or maybe a combination of those things. Because if the only thing I do to get from point 1 to point 2 is one of these, then I haven't changed the size, so they must be congruent. So again, let me restate that in the context of this problem. They're asking me to show that this is congruent to this, that A, B, C, D is congruent to A double prime, B double prime, C double prime, D double prime. And the way that I'm going to do that is by showing that I can get from the pre-image, A, B, C, D, to the image by doing one of those three things or one or more of those three things in this case. So if I can get from here to here and I only use reflections, rotations, or translations, that means that I have preserved the size, which means it has to be the same size because I haven't done anything that would change the size. Okay, so here's my not so expert looking drawing of what we're trying to do is we're trying to start here and end up here. To me, it's pretty clear that one of the first things we're going to have to do is get this over here. We have to get it on the other side of the y-axis. And if you look at the way it's pointing, so to speak, the orientation, the C and the B on this one down here at the bottom, they're on the left-hand side. They used to be on the right-hand side of the figure. And A and D, which used to be on the left, are now on the right. The thing that makes orientation change that way, completely flip-flopping what's on the left and the right, is a reflection. So I'm going to have to do a reflection. So the first thing I'm going to do is I'm going to say, what if I do a reflection right over the y-axis? Well, if I did that, then C would stay right there because that's on the y-axis. Let me get a better pencil. I'm not sure this is any better. And B would come over here. A would come over here somewhere. D maybe here. And again, this is me sketching it roughly, so it's not exact. But you could use graph paper and get a more exact one if you want to. So yeah, that seems right, that that's where it is after the first thing I'm going to do, which is a reflection in the y-axis or across the y-axis. So that would be my first step. Okay, so once I've done that, the reflection across the y-axis, now I need to get it down here. And it looks like it doesn't twist or turn or flip or anything. It looks like it just slides straight down. So I'm going to slide it down, and remember, a slide is a translation. So now I have to describe what I have done. Let me go ahead and figure out how far down. Okay, I'm going to actually cheat a little bit on what that example was because the example doesn't look exactly like it goes to any good points. So let's just say, for argument's sake, that this point was up at 0, 5, and that now C is down here at 0, 1. Okay, so just to make it easier to describe, we're going to say that those are the 2 points for C, which also becomes C prime, and C double prime. So basically, how I would answer this is I would say they are congruent because I can get from A, B, C, D to A double prime, B double prime, C double prime, D double prime, it's kind of a mouthful, by a reflection across the y-axis followed by a translation down 4. And the 4 is me taking the 5 and the 1 and saying we're shifting down 4. And that might not be exactly the same as the picture I showed you originally, but it's the same idea and it's the same concept here that I'm trying to show you. Okay, so this would be my description of how I know this figure here is congruent to this figure here. Because I have done two isometries, a reflection and a translation, to get from one to the other, and so therefore I haven't done anything that would change my size. Okay, last but not least, I want you to go ahead and try this composition of transformations yourself. So go ahead and pause the video, see what you can do with it, and don't forget to do both steps, because your image, when you're doing a composition, your image is considered the final image, basically. And a lot of times you don't even show the one that's in the middle. It's kind of like a rest stop along the way. And then go ahead and unpause and see if you got the same thing I did. Okay, I think the easiest way to start with this is to go with coordinates. So I'm just going to pay attention to the coordinates here, because the very first thing I was asked to do is a 90-degree rotation. Now, it did not say clockwise or counterclockwise. So if you were stumped on that, remember that if it doesn't say, that means counterclockwise, which is this way. Okay, counterclockwise is also the way of the rules that we wrote down. So make sure that you understand that those rules are for counterclockwise, and this is counterclockwise because it doesn't say. So you can kind of write that in there if you'd like to. Okay, so the 90-degree counterclockwise rotation rule is that I'm going to take x, y, and it's going to become negative y, x. So that means 2, 0 is going to become 0, 2. I can't make 0 negative, so it just stays 0. And 7, 2 is going to become negative 2, 7. So that's where I am after the first step. So 0, 2 is right up here somewhere. A prime is at 0, 2, and negative 2, 7. Let's say it's probably up a little bit higher than this, but I'm running out of space there. Negative 2, 7. And there is my image after the rotation. That's not too bad. Because you are doing more than one thing, it's not a bad idea to be very intentional about your work. And I'm going to label that this was my rotation so I don't lose sight of what that was or get confused. The next step is the reflection in the line y equals negative 1. First thing you have to remember here is where the line y equals negative 1 is. Y equals lines are horizontal lines, meaning if I go to negative 1, let's say it's here, on the y-axis, and I went down probably a little far, but I did that on purpose to be under this, negative 1 on the y-axis, and I go to all the points that have that same height. This is the line y equals negative 1. Okay, so you can do this kind of visually, or you could do it in terms of coordinates. That's y equals negative 1. And what I have to do for each of these 2 points is I have to figure out how far above this line it is, and go the same distance below that line. If I'm going across a horizontal line, a y equals line, the only thing that's going to change is my y value. So the 0 here is not going to change, and the negative 2 here is not going to change, because I'm not going left and right at all. I'm just going straight up and down across that line. Okay, so how far is 2 above negative 1? Comparing just the y values. Well, 2 minus negative 1 is 3. So this is 3 units above the line, so I need to go 3 units below the line. So that means from negative 1, I go to negative 2, negative 3, negative 4. So my A double prime is going to be at 0, negative 4. To cram it in there. All right, now this one, the y value is 7. So compared to a y value of negative 1, that's 8 units above. 7 minus negative 1 is 8. So this is 8 units above, which means now I have to go 8 units below. So I'm going down 8 units from -1. Down for y means subtract. So from -1, I'm going down 8, means -1 minus 8. So it'll be at -2, -9, because -1 minus 8 is -9. And that's my b double prime. And there is my answer. So this would be my answer, not this one. A lot of times your teacher won't even make you show this one. And sometimes if you do, you might want to do it lightly, like in pencil, just to sort of give yourself the reference point. So we did our rotation, and then we did our not a translation, we did a reflection across the line y equals -1.